The binomial distribution is a distribution that applies to discrete data, which is data for things that can be counted, like the number of plants in a garden or the number of rainy days in a year. Discrete data is distinguished from continuous data, which is data for things that are measured on a continuous scale, like the sizes of plants or annual rainfall. A special case of discrete data is binary data, which is data where the count is either 0 or 1. Binary data refers more generally to any data that can have exactly two values, like true or false, or success or failure. The binomial distribution specifically is the distribution of counts of success or failure for a fixed number of binary variables. As an example of a binomial experiment, consider planting 5 seeds that have a 60% germination rate and counting the number of seeds that germinate. A 60% germination rate means that, on average, 3 of the 5 seeds will germinate. If this experiment is repeated with 5 new seeds and the seeds are selected at random, there is some chance that only 2 of the seeds will germinate, or that 4 will germinate, or 1, or 5, or that none of the seeds will germinate. The distribution of the number of seeds that germinate is an example of a binomial distribution. In a generic binomial experiment, each individual experiment is called a trial. A trial here is the planting of an individual seed. The two possible outcomes of each trial are conventionally referred to as success and failure. A binomial distribution is characterized by parameters n and p, where n is the number of trials and p is the probability of success on each trial. In this example, n is 5 and p is 0.6. The probability density function of the binomial distribution is given by this formula, which gives the probability that there will be some number x of successes in n trials, where p is the probability of success on each trial. The exclamation mark in this formula is a special notation for the factorial function. Factorial of an integer n is n times n minus 1 times n minus 2 times n minus 3 on down to 1. So, for example, 5 factorial is 5 times 4 times 3 times 2 times 1. This particular combination of factorials is called a binomial coefficient. The binomial coefficient of n and x is traditionally written with parentheses enclosing n above x, so the probability density function of the binomial distribution formula can also be written like this. The binomial coefficient part of that formula gives the number of ways to arrange some number x of successes in n trials, and the probability factors give the probability of each arrangement. For the example of planting 5 seeds and counting the number that germinate, there are 32 possibilities. 1 where none of the seeds germinate, 5 where 1 of the seeds germinates, 10 where 2 seeds germinate, 10 where 3 seeds germinate, 5 in which 4 seeds germinate, and 1 where all 5 seeds germinate. The binomial coefficient gives the number of possibilities in each group. For example, there are 5 ways to get 4 successes in 5 trials, and so 5 is the value of the binomial coefficient for n equals 5 and x equals 4. The value of the binomial probability density function for n equals 5 and x equals 4 gives the total probability of getting any of these possibilities. This result can also be worked out using basic rules of probability. This diagram shows the 5 ways of getting 4 successes in 5 trials. If the probability of a seed germinating is p, then the probability of a seed not germinating is 1 minus p. The probability of getting one of these 5 possible arrangements of success and failure is the product of those probabilities, which in this example is 1 minus p times p to the 4th power. And the total probability of getting any one of these possibilities is the sum of those probabilities, which leads to the same result as the result from the binomial probability density function with n equals 5 and x equals 4.